Hi, my name is Iman van Lelyveld. I run the Data Science Hub at the Dutch Central Bank, the supervisor and central bank in the Netherlands. I also am a full professor for 1 day a week financial markets and institutions at the VU in Amsterdam, and I have the honor to be a visiting professor here at EUI. Today I would like to talk to you about how to make data science work for authorities and central banks across the world. So, data science. Let me tell you what it means to me, because it means many different things to many different people. So to me, it is a combination of new techniques and a new way of working, which could lead to a much better way of working, if you apply it responsibly and mindfully. So that means that you should have things like unit tests, which might sound alien to you, but basically means that you really look at how your code works. Now, a few years back, data science was heralded as the sexiest job around. Data was the new gold, and this was a great time to start a new department, as I did in 2020. Now these days, expectations have gone down a little bit because people have figured out that if you really want to get this to work, it's hard work. Now, if I look at the little bubble within the Dutch Central Bank, I think we're doing okay. What do? Well, we do a bunch of projects with all the departments across the central bank. That means both for supervisors, but also for payments people and resolution. So these are very, very different types of businesses, and we try to do projects with these people. Our clients are happy, so we always send out a survey and we get 9 stars out of 10, so I think that's quite okay. But let me talk you through a bunch of these projects to give you a sense of what we do. So the first project I would like to talk to you about is about false and fit banknotes, and the second one is going to be about a big project about know your customers. Let me explain. So false and fit. What happens? Well, we have banknotes in circulation. They come back to the central bank and are checked for whether there's a tear, whether there's tape on it, whether they're dirty. And if that's the case, then they're shredded. So we actually visited the plant where they look at whether these banknotes are fit or not. And they have giant machines which sort of go through these banknotes with dizzying speed. And at the end of the machine, which is about 10 meters long, there is a little window and you can see the banknotes being shredded, which is physically painful because it looks to be quite an okay banknote, but it's rejected. Now, what could we do? Well, there is a whole bunch of little checks in that machine that we can tweak. And if you tweak one of these little knobs, then of course you can see whether quality improves or not. But you can't really twist all the knobs at the same time and see whether that improves things or not. Here, what they call a genetic algorithm kicks in, and with this kind of machine learning approach, you can really see which knobs we should turn to make this better. End result is that we can sort of decrease the quality by not too much, but at the same time keep the bills in circulation much longer. And if we can sort of make this work for the whole euro area, can save us millions in costs of printing them, but also reduce our footprint because printing banknotes is expensive. Another project that I would like to talk to you is about KYC. KYC is know your customer. And what does this entail? Well, we have the banks as guardians of integrity of the financial system. So if you open a bank account, they have to check whether you are a crook or a terrorist or someone else who should not get a bank account and use the financial system. Banks have systems for this, but supervisors need to go and check whether these systems are valid. So what have we done? Well, we've gone to the banks and said, could you please give us all the payments of all your clients, and then we can sort of have a a challenger model. And this was quite challenging for us because the size of the data was huge, and we needed to compute these things at speed. At the end of the day, we could provide the supervisor a much shorter list of, say, 500 to 1,000 profiles of clients that the bank should have caught, and they didn't. Again, this makes the work of the supervisor so much easier than it was before. In addition to all these projects, which are sort of the bigger showcase things, we did all kinds of smaller things, but well, you can check the website. The second thing that we do at the Data Science Hub is not just these projects, but also all kinds of activities to enthuse data scientists across the bank. And this is very important because in the end, we want people to work with their data and their problems themselves. So we organize hackathons where people work together on a specific problem. We have an open source lunch. We do trainings and sort of everything that we could figure out to make this work. Well, as I said, within the bubble, we're doing okay, can't complain. But if you ask me, so where should we go, then I have this sort of dream that we can make this work for all of us and not just for this one little institution. And the key there is, I think, open sourcing our code. What does this mean? Well, it means that you can share the code that makes the applications or the analysis work. We are all looking at the same risks, at the same kinds of institutions, but unfortunately in sharing the results of our analyses, we revert to PowerPoints, very shiny ones, which sort of show us how wonderful our analysis is compared to others, but it doesn't really tell you what we did in analysis. It doesn't really allow the others to replicate that same analysis in their own institutions. So if we, instead of sharing these PowerPoints, would be able to share the code, which would be able, and we could run this code in our own institutions, then I think we could sort of make big steps. This approach is not without its problems. It's not something that we as a supervisory community or within government in general have much experience with, but it's used out there in many, many big software platforms, like for instance Netflix, are all running on open source code. But let me first walk you through a long list of problems or questions that we should answer. So one question is, who's in charge? I mean, who's going to develop which bits of code? Well, the beauty of that is whoever thinks that a piece of code is useful is going to develop that piece of code. The idea of open source is that it's self-organizing. For this, you have specific licenses that allow others to build on your code instead of restrictive licenses which tell you, well, you can only use my code if I tell you that you can use it or if you pay me. Now, who will take care of maintenance? Again, in an open source community, this is seen as a communal duty. So everybody would take care of maintenance. Of course, you need someone to be like the benevolent dictator for life, as as these kind of people are called, but these people have the communal interest at heart. What programming language should we use is another question. I don't have a strong view on that, as long as it's an open source kind of language, which is intrinsically built on connecting with other languages, in contrast to closed source things where you have to pay and the provider or the maintainer really wants to lock you into that language. And for instance, there are, of course, already many applications built on these types of languages, so we need to be careful in how to move to another kind of model. Now, so far I've said open source is going to solve everything. Is it magic? No, it's not. There's many cases where you don't want to open source it and where you want to have a centralized body, like for instance European Central Bank or a government take charge, because it's a big project where there should be centralized control. But in many other smaller projects, this is not the case. Now, in addition to this open source coding idea, there's other issues that we could all work on. So we could work on privacy preserving compute. No longer take all the data to one place and then compute things. No, rather keep the data wherever it is, bring the code to the data, compute something, and deliver that result to a central place. This would hugely speed up our discovery of things because we don't have to sort of take on the expense of bringing together all that data. Another thing could be that with this kind of way of working, we could bring in academic research much quicker into a place where you actually work with those ideas. Academic papers are wonderful, they are very in-depth, but in the end they're pretty much a one-shot game. And if we find a way where academic papers and the methods developed there could be just picked up and put into a production place, that would definitely increase the impact of academic work. Now, these are all things that we can figure out, and I don't have all the answers, but I invite you to come and join me on this journey. There are already some initiatives underway, like for instance the BIS Innovation Hub, and I'm sure that once we start traveling this path, that at first it's going to be slower, but then in the end we're going to get much further rather than going at it alone. Thank you very much for your attention.